In this video, I want to talk about prompt engineering, and specifically prompt engineering for LLMs. But I'm not going to talk about how to do prompt engineering. There are a lot of videos for that, and I might cover that in a future video. But in this one, I want to cover sort of what is prompt engineering and why do we do it, specifically in the context of LLMs. And in order for me to talk about prompt engineering, I need to first talk a little about latent spaces. I've covered latent spaces in other videos before, but again, just to highlight sort of like what is happening here, imagine that you've got maybe a space. And in one of the spaces is a certain amount of data, right? So this might be everything ChatGPT knows about books, right? So there's a bunch of points in here. Maybe it knows about science books, it knows about fiction books, it knows about history books, those sort of things. And then another part of the latent space is everything that ChatGPT knows about cats. And this is sort of how latent spaces work, right? They embed all of their knowledge into essentially a coordinate space. And the reason we do this is actually because to make our model as efficient as possible, we need to sort of represent this in a space, in a dimensional space, essentially. And this is how we get our models to work as fast as they do and to carry as much information as they do, despite them still being quite big. I think I've read some like ChatGPT is some like 500 gigabytes as a model, but still it encompasses a ton of information, right? You can think about these as big compression models, right? They compress a lot of data into a tiny space, even though they're still quite large. And you might be looking at this and being like, well, what about spaces that are about cat books? And this is where I kind of have bad news for you. I'm representing a latent space here as a two-dimensional space just because it's easier for us to understand. But the reality is most machine learning models are what we call highly dimensional, meaning there's likely thousands upon thousands of dimensions inside of the space of this latent space. And our puny little human brains can't really compute that. Like, we can think to maybe 3 dimensions. Maybe some of you have seen enough 4-dimensional diagrams you can think in that space, but there's really no way to think beyond those dimensions. So we don't really have a good way of visually representing this, but you can imagine this now in 3-dimensional space, and there are, in any of these dimensions, different parameters, different concepts. And this becomes the key to like how we actually utilize these machine learning models, right? We create a prompt, we ask for the response to that prompt, and the model goes through its latent space and pulls out all the relevant details enough to give you a response back. So in this case, let's take a look at an example. So again, this might be the space where everything ChatGPT knows about cat books, where we've got the book space and the cat space. And you can kind of think about these as going in different directions, right? Maybe along the X is books, and along the Y is cats, and somewhere in the middle they meet. And that's a good way of representing dimensional space, except we've got probably millions of dimensional spaces when it comes to ChatGPT. So whenever we ask for a response from ChatGPT, we're kind of assuming that we were asking for that particular section of the latent space. But because of these high dimensional spaces, we're also getting this other data in there. And this is where it can lead to hallucinations. This is what can lead to inaccurate responses. We kind of describe these in machine learning parlance as these are entangled spaces, meaning the spaces are not clearly separated out, and sometimes when you dig through them, you get kind of a messy mix of different concepts. And so prompt engineering is essentially the concept of us guiding this model to the most accurate part of latent space. So instead of having a very generic output, we actually sort of provide a little bit more details and some other phrases that help guide it into that right section. So let's take a look at an example here. So if I ask them, like, tell me about different types of cats, just telling ChatGPT this very generic concept, well, that's, again, it is quite generic, right? So it might say, part of the model might look for scientific names of cats, right? And maybe that's on this angle. Fictional cats in movies might be another way to approach this. And so if I just say, hey, tell me about different types of cats, the model might give me a very broad, generic idea of cats, or it might even just veer into like making stuff up, right? It might combine scientific names of cats with fictional cats because of sort of this entangled latent space, and doesn't really have enough context to give us the exact answer. Now, one way we could change this is, let's say we change the prompt. We say, you are a veterinarian. Provide a list of cat species in a JSON format. We'll talk about these as we talk about how to actually do prompt engineering, but we can kind of talk about a couple different things here. So when we say you are a veterinarian, we kind of say you're an expert. Talk to us as an expert. When we say provide a list of cat species, we're saying more specifically like give us this list, instead of saying tell us about cats. So it give us a list of cat species, and then we say in a JSON format, and that provides structure. So in general, when you want to do prompt engineering, like these are kind of some key ideas to think about, right? What's your intent? What's the tone of voice you want to have used? What's the content you're specifically using for? Can you provide a structure for it, whether it's a coding structure or even an outline structure? These are just some ways to, again, reorient the model into the correct latent space. You can kind of see here, like maybe I'm saying that like along one axis of this model is structure, right? How creative is it? How unstructured is the data? How structured is the data? Maybe it's even programming formats, like is it asking me for JSON? Is it asking me for XML? Is it asking me for HTML? Then we've got tone of voice, right? So this is actually one that's pretty frequently used in both ChatGPT and Gemini, where it asks, how creative do you want me to be? Do you want me to be professional? Do you want me to be more loose and informal? That sort of thing. And then obviously the content, right? What exactly are you asking me for? You want to be as specific as possible because that's going to help make sure the data you get back from these models is correct. Now, one last bad part of news here. Technically, every model has a different latent space, which therefore means prompt engineering does not work generically across all models. Now, I will say, I think for Gemini and ChatGPT and some of these other like conversational text models, I think the concepts we could look at here for prompt engineering are generally applicable across different models. But when we get into stuff like image generation is a lot more tied to the actual images you're producing and the data associated with that. So in those cases, prompt engineering might be really, really focused and really dependent on what model you're using. And this gets us into this whole world of like, prompt engineering feels like a lot of work. We're putting a lot of work on ourselves when used to be the work should be on the machine, right? When we talk about AI, it's supposed to be out, the AI does all the work for us, and now we have to learn the AI language in order to prompt engineer. We'll talk about that more in future videos, but I wanted to cover a little bit of like latent spaces and prompt engineering and why it actually works the way it does. And I hope you learned a little bit here. Again, feel free to ask me any questions if you have any other questions about latent spaces or particularly prompt engineering. So again, in another video, we'll cover the actual what to do and how to do prompt engineering, and we'll look at that soon.